In this question, we're asked to find the Taylor series for 2 over x centered at a equals 3. And we're going to apply some clever thinking in order to do that in a relatively simple way rather than a long way of taking derivatives and looking for a pattern. We'll be able to do this by matching, well, first of all, remember that if we're centered at a equals 3, then that means that our answer is going to be of the form the polynomial will be some constant c0 plus c1 x minus 3, right? Centering at a equals 3 means that we've shifted everything over 3 units. Then c2x minus 3 squared, c3x minus 3 cubed, and so on and so on and so on. Right? So all of these things have these x minus 3's in it. So you want to think about this as sort of like saying take x and replace it by x minus 3. So if I can take a Taylor series which we know, but has a x minus 3 in it instead, then we'll be in much better shape. So there's a few that we'll see that are like this, but here's the basic idea. Since we're centering at x equals 3, I'd like to see x minus 3. But if I'd like to see x minus 3, I can't just have a minus 3 without undoing it by putting a plus 3. So I have minus 3 and I have plus 3, so I haven't changed anything. I'm going to think about that x minus 3 as a single piece, because we need to see these x minus 3's in the end. And then we're going to apply our thinking for 1 over 1 minus x. If this were a 1 and this were a 1, well then we could simply replace x by x minus 3 and we end up getting something that looks exactly like this. But we've seen other examples where we take this and we turn this into a 1 and this into a 1. And we do that first by factoring a 2 out, and that's 2 in the numerator. And then we factor a 3 out of the denominator. And when we factor that 3 out of the denominator, we get an extra 3 underneath this x minus 3. So this is 2/3 times 1 over 1. Now I'm going to turn that into a minus by making that negative. And we've done a lot of algebra to turn this, we've made it way more complicated, but by doing so, we have a 1 over 1 minus something, and that something has the x minus 3's that we need. And so now we can apply this thinking up here to the piece that we've got inside the brackets, simply using what's in the red box for x instead of just x for x. And that makes 2 over 3 times sum. X now is negative x minus 3 over 3 all to the n. And that's from 0 to infinity. We'll do a little bit of algebra to make it look a bit nicer by distributing that n in. If we distribute that n in, it becomes 2/3 sum minus 1 to the n, x minus 3 to the n, and over 3 to the n. We can bring the 2/3 inside. Sum minus 1 to the n. 2, that's the numerator, goes in the numerator. X minus 3 to the n. And then I have an extra 3 in the denominator, so that will be 3 to the n plus 1. This looks kind of like a mess, but if I start putting some terms in, if I plug in 0 for n, plugging in 0 for n makes it positive, so I get 2. Putting 0 in for n makes that a constant of 1. So that's 2 over 3. If I plug 1 in for n, now it's minus, because that will make it alternating. Plugging 1 in for n makes 3 squared, so that's going to be 2/9, and that will be x minus 3 to the first power by plugging 1 in for n. Plugging 2 in for n will make it positive. This makes it alternating. This 2 is always a 2. This will be 3 to the n plus 1. If n is 2, that's 3 cubed, so that's 27. And then I have x minus 3 squared. And my point is that when we've expanded this all out forever, I've got these x minus 3's in place of x, which is exactly what it means to be centered at a equal to 3. And so this is really the fastest way to get to it. It's different than what you'll see in the examples on the homework system, but it is really the most efficient way.